Hi guys, this is Chevin Academy. In this video, we are going to be looking at the introduction to design of Ribbed Slab. Ribbed Slab is another common type of slab aside from the solid slab and the flat slab that is used in construction today. In our last video, we've discussed about the design of flat slab, where we talk about using a practical worked example where I show you how you can practically design a flat slab. So in this video, we talk about a ribbed slab. Why do we have ribbed slab in construction? So first, let us understand what a ribbed slab is. A ribbed slab is just another form of reinforced concrete slab, but in this case, some of the volume of the concrete below the neutral axis especially is either removed or replaced with another lower density material. We know concrete is very expensive. So in forms of larger span, where the provision of solid slab is not economical, then ribbed slab principle can work by removing some part of the slab and replacing it with a less density material or a less cost material, or removing that part completely. So the image to the left is trying to show a construction phase of a ribbed slab where some part of the slab is replaced with bricks material. So the image to the right is trying to show another forms of ribbed slab, but in this case, some part of the slab are completely removed. Ribbed slab are generally suitable for larger span, but for the ones that are supporting lighter load, for example, in residential or commercial properties. Ribbed slab are not actually suitable for heavy loadings like in case of a warehouse. So the principle in which ribbed slab use is that whenever we are designing a concrete member in flexure, part of the concrete that are below the neutral axis, those parts are technically ineffective in designing against the bending moment, even though they are useful in resisting against shear. Those parts below the neutral axis can permanently be removed in order to save cost or save the weight of the construction material. So based on my previous explanation, we can understand that we have two forms of ribbed slab. The first one is when you have the ribbed slab with hollow blocks or with another material, not necessarily an hollow block, but another material that has a lesser density or cost less compared to concrete. So with this material, you try to reduce the weight of the slab so that in analyzing the whole building, you are going to result in a lower weight compared to a solid slab. Then another form is you can have a ribbed slab where you have a removable form. That is the formwork that you use to create this kind of slab is removed after construction. Based on my explanation, we can understand that a ribbed slab comprises of two major parts. You have the rib, which is technically the same thing as a beam, and you also have the part of the slab, which is also called the topping. So this part of the slab that connects to the rib is called the topping. So this topping can be connected to the rib either through in situ casting or through the use of a precast rib, and then you cast the slab on site. So let's now go to the design criteria you have to consider. So let's talk about the size of the rib and also the spacing. So this image tries to give a general explanation on both the size of the rib and also the spacing. So from this image, the effective size of the rib slab, because this shape is not a rectangular one, so that's why you need to establish the effective size. So the size of your rib is given as BV. So this size is usually governed by three things, which are the bar size, that is the size of the reinforcement you provide, the cover to reinforcement, and also fire resistance. So those are the three things that actually govern the size of the rib. Based on either the BS code or the Eurocode, the minimum size you can have for your rib is 125 millimeters, which is the same thing as 5 inches. So that is the minimum size you can have. Then let's now go to the spacing. The spacing between this your rib, according to the code, should not be less than 1.5 meters. So 1.5 meters is the center to center spacing of your rib. So this is the maximum size that you can have, or maximum spacing. Then another thing we have to talk about is the depth of your rib beam below the part of the slab. Now I told you rib slab is comprised of two major components, the rib itself and also the topping. So this topping is also called the topping slab. So the depth of this rib should be less than 4 times the width of your beam. So let's say your rib is 150. So that means the maximum depth that you can have based on the code is 4 times that rib. So 150 times 4 is 600. So you cannot have a rib depth minus the topping slab to be greater than 600 in the case of a rib width of 150 millimeters. I hope this is understood. So whenever you want to design a rib slab, so the first thing is to understand what is the minimum size of your rib to use, and then what is the maximum spacing that you can space your rib in center to center. So once you understood that, another thing you have to understand is the thickness of your topping. Based on this image, you can see that the topping is given to be greater than or equals to 50 millimeters. This actually happens whenever you are considering your topping to contribute to strength. If you check the code, you see that the rib slab is categorized into two major parts. You have in situations where the slab topping is contributing to the load, and also situation where the topping is not contributing to the structural strength of the slab. So design criteria for slab topping, this is just talking about the minimum thickness of your topping. So this table is referred to as table 3.17. It gives the minimum thickness of your structural toppings. So this one is in the case when the topping is not contributing to the structural strength of the building. One way of understanding this is in case of asphalt on a bridge. You know, the asphalt is not really contributing anything to the strength, so it's referred to as a superimposed dead load. That is a dead load, but is not contributing to the strength of the structure. So this also applies in a rib slab. So whenever you have your slab topping not contributing to the strength, then you have to consider what is the minimum thickness you can use. So based on the code, you can either have 25 mm thick, 30 mm thick, from 35 to 50 whenever your topping is not contributing to the strength. So you can have a topping from 25 to 50. When you have a slab without permanent blocks, then the minimum thickness you can use is 50 millimeters. So that is why in the previous slide you see that there is no permanent block in the rib slab. The minimum thickness of your topping slab is 50 mm. But in case if your topping is actually contributing to strength, so if your topping is contributing to strength, so that means whatever thickness of topping you have to provide, it must always be greater than any of the things mentioned here. That is, it must be greater than 50 mm, and then it must also be greater than 1/10 of the distance between the rib. So let's say the distance between your rib slab, the clear distance in this case, is 750 millimeters. So to determine, and you know that your topping is going to be contributing to the strength, that is, you have to design for moments for the topping, and you also have to provide reinforcement, not just for cracking criteria, but you have to provide reinforcement because the topping is contributing to the load. So in that case, your topping thickness will be between 50 millimeters or 1/10 of the clear distance. The clear distance in this case is 750. So 1/10 of that is 75 mm. So that means for you to design that slab properly, your slab topping should be 75 mm. So when it is 75 mm, then it fulfills the criteria for minimum topping. So we are going to be stopping here on design criteria for rib slab. In our next video, we talk about a worked example where we are going to be looking at the practical design of a rib slab to the Eurocode as well as to the BS code. Don't forget to subscribe to this channel if you've not. You can like this video, share it to your friends. Once you subscribe, whenever we make the latest video on the actual design, you'll be the first to watch it. Thank you. See you in the next one.